Okay. So the first one we stopped right here. We said decompose this question. 5 over x squared plus x minus 6. And then we factored it and we got these guys using trial and error. X plus was plus 3 minus 2, right? Then we use the case 1 to put a over the first one plus b over the second one. Okay. So let's start right here. I rewrite it down here because it looks kind of messy. So it's 5 over x plus 3 times x minus 2 equals a over x plus 3 plus b over x minus 2. Now, it doesn't matter what order you put these. It's going to be fine. Now, the technique to solve for a and b is going to be called equating the coefficients. So we will equate the coefficients by first getting rid of these fractions, and then we'll show you the technique. So step 1, cancel all fractions. By multiplying with the LCD, the lowest common denominator. Let me lower the light. I think it's bright again.
Right now, we're trying to solve a case 1.
Yeah, so we're going back to case 1 and we're going to solve for a and b. So we're going back to the question. Now that we are a little bit more comfortable with the setup, right? Let's solve for a and b. Okay. Let's see.
I'm sorry, what it says cancel all fractions by what?
By multiplying with the
Okay.
LCD.
Okay, thank you.
This, sorry. MULT. Okay. So LCD is going to be and this on these type of problems, it's always going to be what's on the left side. Okay. Every single time. So you're going to multiply these two things, these two factors, on every single part here. Just on the top. And things are going to cancel, and you will not have any more fractions. Okay. So here we go. So x plus 3 times x minus 2 times 5 over, this is the left-hand side, x plus 3, x plus 2 equals, then do the same thing, x plus 3 times x plus 2, I'm sorry, minus 2, times, should be minus right here, times the a over x plus 3. Then again, x plus 3 times x minus 2 times the b over x minus 2. So at this point, we'll lose all our fractions. Do you see how this will cancel, right, completely? Leaving me just at 5 right here. So 5 will equal, and then this x plus 3 cancels with that x plus 3, leaving you with x minus 2 times a plus x minus 2's cancel here, leaving you with x plus 3 times b. So no more fractions. So that's the whole goal. You just take the LCD again and multiply it on every single fraction. And don't actually multiply anything out, just cancel the common terms. That's all you got to do. Okay. You guys have any questions on that first step? step 1. Okay. So at this point, we do step 2, which is the equating the coefficients part. So multiply out all factors and group the like terms. Okay, so you're going to multiply that a in, giving you an ax minus 2a plus bx plus 3b. So all I did was distribute the a inside. See what I'm saying? Just in here. That's all we did. Nothing special. Now the next step is grouping the common terms, the like terms. So ax plus bx minus 2a plus 3b. Yeah, you guys still with me at this point? Any step that's weird or confusing, please let me know. Okay. All right, so let's factor out the x so I can show you how this works. A plus b, factor out an x. I'm factoring it on the right, which is a little weird, but I think it'll help you see something. So this is the coefficient of the x. Some number plus some number is just some number, right? So this is like, could be a 7x or a 2x or whatever, 1/3 x, who cares? These are both constants. There's no x terms, correct? So what you're going to do is set these variables, the a and b, equal to any x terms on the left-hand side. Are there any x's on the left? I'm writing equate the coefficients. I'm going to equate a plus b to the coefficient of the x term on the left. There are no x's, right? So that means a plus b is equal to 0. That's what we mean by equate them. Now look at the constants. Negative 2a plus 3b is equal to, what is the constant on the left? I wrote that all stupid. Fix that. Now you see how it's going to be 5, right? So you create a system that you can solve for a and b using this method. But in order to do so, you got to cancel fractions and then group the like terms. You guys have any questions on any of these steps so far? At this point, it's pretty much done. Just got to solve for AB, but there's a lot of prep work. You see how there's a ton of algebra going on.
Sorry, really quick. Why does a plus b equal 0?
Because we're equating the coefficient of the x term with the x on the left. So there's a 0x over here.
Got it.
Right? So 0. If there was a 7x over here, you would put equal to 7. Okay. Constants will equal to constants. If there was a cubic, then you would set it equal to a cubic or quadratic. Same thing, which will happen later. So at this point, you just solve this guy, and you're done. You can use your calculator, matrix, or substitution, elimination, doesn't matter. I don't care how you solve it, just solve it. Since it's an easy one, Let's see here. Make sure I did everything correctly before I move on. 1 second. Yeah, looks good.
Can I ask you a question real quick or whatever you're ready?
Yeah, what's going on?
I mean, this the third step right there. I got the a plus b equals 0. That makes total sense. But I was writing over here. I didn't catch the second part, like that second half. What are we doing on the second part? The negative 2a plus 3?
So these are the constants, right? Because they don't have any x's.
Right.
So you set this
Okay.
equal to the constant.
Gotcha.
These
Makes
are-
total sense. Okay.
This is the x's, I guess.
Awesome. Awesome. I figured variable or x, whatever.
Okay,
Yeah.
cool.
I mean, yeah.
All right, so let's multiply the top by 2, giving us 2a plus 2b equal to 0. This is called elimination. Right? You can multiply whatever you like on an equation, doesn't matter. It's up to you. As long as it's not 0, you can choose any number. Add them together. That'll be 5b equals to 5. Do you guys remember doing this a long time ago?
A few months ago.
Yeah. So then b is, I need to get pins this weekend. This is stupid. Yeah, let me switch out here. B is equal to 1, right? So if B is 1, what does A have to be? A plus B is 0. So
-1?
yeah, this implies that A is -1, right? So that's it. You have, once you have A and B and all, you're done. Remember, the whole goal of all of this crap is to decompose the original question into 2 fractions with some numbers. So the answer will be right here. -1 over x plus 3 plus 1 over x minus 2. This is the decomposition of 5 over x squared plus x minus 6. Okay. So all of this is just to find these 2 numbers so I can separate a fraction.
Sorry, could you go over that last part where we get
Mhm.
a plus b equals 0, 3a minus 2b equals 5?
Sure.
What are we multiplying out there, or how are we getting it down to 0?
This part here?
Mm-hmm.
Oh, I was just doing an elimination. So the idea is you want to match up to the coefficients that have opposite signs. So if this was a 2, 2 minus 2 would be 0, right?
Mm-hmm.
So I introduced a 2 by multiplying everything by 2. 2 times A, 2 times B, 2 times 0. So now add it all across. 2 minus 2, 3 plus 2 plus 3, 0 plus 5. I would recommend just using a calculator because this is already enough work, right? So let me send you something. One second. I like this guy. It's pretty simple to use. All right. I'm going to use elimination. We have, so you guys remember your matrices in college algebra? Yeah, so I guess before I do the matrix, right, we should create the matrix. This right here can be turned into 1, 1, 0, -2, 3, 5. You guys remember this? Or do you see how this came about?
I did 2 row 1s plus row 2 to row 2.
Yeah, these are the coefficients of your variables, right? This is the A column and B column. So there's 1A, a -2A, 1B, a 3B, constants, constants, right? Do you remember doing that?
Yes.
So once you have this, you can just solve it with a calculator. I think that's the easiest approach when you have a bunch of A, B's, and C's. You guys have any questions on setting the matrix up before I solve it?
Could you just scroll up just a little bit? I was still writing down what you were writing up earlier up there, please.
Oh, the answer part? Yeah.
Yes. Perfect. Thank you.
Yeah, so once you have A and B, just plug it in. That's all you do. So on your homework, they're just gonna ask you for this part.
So that's the answer.
Right. So all this work is just to find A, B. Okay. And anyone have any questions on the matrix setup?
Oh, God. Okay, gotcha.
Okay. And if you don't like matrices, you don't have to do it that way. That's my suggestion to you.
Okay.
This is a matrix of 2 by 3 dimensions, right? So just plug it in 1, 1, 0,
What the heck?
-2, 3, 5. Solve it. The first one, A is -1. They use x1, x2, but who cares? -1 and 1. That's what we got, right? So you can do it that way. You can also do use your graphing calculator if you want, or elimination or substitution. That is your call.
The test, can we like use them on our calculator?
Yeah, you're allowed to use your TI-84, 85, 89. If you don't have one, then I'm going to try to get you a website link that you can use or something.
Okay, cool. Thank you.
So like, what? So people could have cheated last semester on that when I was doing all the work. I mean, what? Wow.
What do you mean?
Okay, I'm just.
Sorry,
Well,
guys,
I
see that top part again?
I mean, it's only going to give you this part here. So since you've already done matrices, I'm not going to force you to solve it by hand because we've already done a ton of work. So making you do that by hand again, it's like, come on, it's too much.
Okay. I see. I feel.
And you've already learned matrices, so I'm not going to test you on matrices. That's not in this class. It's a tool that we can use to make it easier, but I'm not expecting you to know that.
I learned that. I just struggled so much. I can't believe people could have actually cheated on that. Wow. I mean, I wouldn't have cheated. I'm just saying.
Well, it's good to learn once, but after that, I'd say use your calculator.
Straight up, I'm with you on that.
Yeah. But they could give you questions without numbers and mess you up anyway. So
Nice, great.
you guys have any questions on the first example? We solve for A and B. There's 2 methods to solving this. This method that we just did works every single time. There's another method that people like that's a little bit easier to find A and B, but you have to know when to use it. And sometimes using it at the wrong time makes the problem just really difficult. But before we do that, do you guys have any questions on number 1? Any of the steps, beginning, end, I don't care. All right, so let's restart this question right here. And I'm going to show you a different method. So instead of equating the coefficients, stop at step 1 and we'll use, it's called the Heaviside method. Just make sure I don't forget what that looks like. It's 5. You guys cool if I turn the page, or I'm going to wait a bit? It's okay. All right. Just let me know if I'm going too fast, or whenever I don't make any sense or I'm going too fast, just tell me. Not a
So
big deal.
that was a total of 3 steps to answer that decomposition thing.
Yeah. So the whole goal is you decompose one fraction into a sum of separate fractions. So the big picture, right? Bring it all together. Given a fraction, you factor it, You break it into multiple pieces. Then you find the A and B that makes it equal. That's it.
Mhm.
But in order to do so, requires all this nonsense. All right. So that's the goal. I know after we've been doing a lot of work, sometimes we forget what the heck is the goal. Happens to me sometimes. Ready? We're going to start right here, and I'm going to show you the Heaviside method. The homework is going to use this method over and over again. And when you see, you know how they have help me solve this and all that crap, the examples and the MyLabs Plus, you know what I'm talking about?
Mhm.
They're going to use this method. And just remember, I recommend you learn the other one I showed you first before you use the Heaviside method. Spelled it all stupid.
Because you
people
said
learn
the other one
multiple-
always works.
What's up?
You said because this one doesn't always work, you have to know when to use it, but the other one always works.
Right. Yeah. This one is really beautiful when it works, but when it doesn't, it's like I just wasted my time. Heaviside method. So this is all the examples in your homework are only going to use this, which kind of annoys me because they don't talk about the other one. But oh well. Okay, so what you do is you try to zero out these factors. So you say, okay, you know what? Let x equal 2. Do you see why I let x equal 2?
Mhm.
Right. You can plug in the 2 here. What happens to this whole part?
Zero.
Yeah, it's gone, right?
So
So we don't have to solve for A because it's gone, and we'll be able to solve for B straight up. So 5 is equal to 2 minus 2 plus 2 plus 3 times the B. So this is gone. So 5 is equal to 5B, right? So what is B? See how this method is really easy when it works. So let's do it the other way, right? Let's let, what should X be to solve for A? What do you think?
-3.
Yeah, -3. So 5 will equal -3 minus 2 times A plus -3 plus 3 times B. So this is gone. So now I have 5 equal to -5A. A is going to be -1, right? So see how this looks much easier than this part here. See how we had to do some algebra, expand all this, group them together, create a system, and then solve the system. The system can be solved many different ways. I chose matrix and elimination, but it's your call. This method always works. If you see, and I guess some advice for you. If you look at this and you say, you know what, picking an X will zero out most things and leave me with one variable, then I should stick with Heaviside method. But if I choose an X and only one thing zeroes out and I still have like a B, C, and a D, then clearly that is not a good method. I should go the other route. Okay, so you want everything to cancel out except one specific letter, then that's a good candidate for Heaviside method. Okay.
But
Mr.
if it-
Gonzalez.
Mhm.
Isn't 5 minus 5 0?
5 minus
Like-
5 is 0, but what do you mean? But where
Okay,
at?
so at where you eliminated 2 minus 2A,
Yes, here.
and then you go down,
Mhm.
and then down.
Here.
Why is that 1 and not 0?
Oh, okay. So the step that I skipped you have to divide both sides by 5 in order to solve for b.
Oh, see, I thought it was subtraction.
Oh, that's okay. Yeah, so don't forget, when you have 5 times b, you have to do the opposite, so divide.
Oh, okay.
So over here, I skipped it too. You have to divide by -5 right here. That's what makes it a -1 over here.
Can you please repeat what you mentioned just a moment ago about what would make a good candidate for the Heaviside method?
Oh, so if you see that choosing a specific x will cancel everything out except one of the letters, like A or B is left over, then that's a good one. But if you choose something and everything cancels except, but you still have like a B and a C, or you have too many letters left over, or you
Gotcha.
isolate every single one, then you probably want to go with something else.
I have a question about that though.
Mhm.
So if there are multiple candidates, like let's say it's, sorry, go ahead. Okay. So if you do have like x minus 2a, x minus 2b, x plus 3c, wouldn't that fall under a different category? Like, wouldn't that fall under a different case, like case 2?
I think, I mean, you can still do Heaviside on any of the cases, 1, 2,
Okay.
3, 4, whatever. It just depends on like what ended up factoring here. Like for example, let's say I had, just for fun, you don't have to write this part down. Let's say we had x plus 7c, right? Now, if I let x be 2, you're going to be left with this part and this part, right? So now you cannot solve for b or c because you have 2 unknowns and 1 equation. So Heaviside would not be good because if you had this happen.
Right.
So you want everything to cancel except the variable you want to solve.
Right,
That's
but
when you know it's working for you.
if it was x minus 2c, wouldn't that be a duplicating?
Yeah, so when you see repeated
leading
stuff
factor?
or just 2 factors, those are indications that it could work. So yeah, I think I agree. I see what you're thinking. If you see repeated stuff, then maybe. I don't want to say all the time.
Okay.
But if it's just 2, for sure, yes.
Got it.
Unless those are the same, then that'd be a problem. But
Okay, cool.
But you'll see after doing it a couple of times, you'll realize that that method is not working for you. Do you have any other questions on this?
Are all problems on the homework going to be solved by the Heaviside method?
They will. They're examples, and they'll use Heaviside every single time, even when you shouldn't. They'll like power through it, and you'll realize it's a lot of work, and it's not worth it.
Fair enough.
It's like there'll be times where, I mean, some of you are probably thinking, well, this seems like a lot of work, but sometimes this is the easier route.
Like you don't make fractions out of unnecessary things.
Yeah,
top
or
of
they'll
that,
just,
yeah.
or you have to keep, like for example, what they'll do, they'll like solve for A, or like let's say here how we solve for B, right? They'll go ahead and go put B in there, and then try to find A, and then they'll get A and put it back in here, plug in the B, and then they'll try to isolate this guy. So it turns into a ton of work, and at that point you're like, well, why am I even using this method? This method should be a shortcut, not equally difficult, right? Or more difficult.
Gotcha.
But you'll see their examples, and you'll realize, you know what, that's stupid. I shouldn't go that route.
Cool.
But anyway, let's see. We still have time for another one here. 7:55. I think I'm out of time. Yeah, I guess we'll have to stop here. Today is Thursday, so on Tuesday we'll go over this again, and we'll finish it up, and then we'll start the actual pre-cal stuff. Okay, so try on your homework, start doing these problems, and I'll probably extend the date till like maybe next Friday. But start practicing it and bring a bunch of questions with you next time if you get stuck, and we'll try to figure it out. Okay. I guess. Well, if you have any questions, you're welcome to stay for a little bit. If not, you're welcome to head out.
Bye, everybody.
Awesome. Thank you so much.
Thank you.
I actually had a question.
Yes.
So on our homework, are we able to do part of it one day and then maybe another part another day or another hour? Or do we have to do it all in one sitting?
No, yeah, you can do one question and then come back later, do another question.
Okay. Okay, thank you.
Are the tests gonna be on the Pearson?
It'll be on Canvas, and what I'm gonna expect you to do is basically you write the question down and just show all your work, and then at the end of the test you upload your work.
Yep.
That's it.
Okay.
Okay, just for clarity, you mean like I can write it out and scan it into my computer? Is that what you mean? Or?
Yeah, you'll use either a phone app to scan it or an actual scanner.
Okay, cool. All right.
Because I'm going to be grading the written work, not the answer choices that you choose. And if you don't show work, well, it's not going to be right.
So even if the answer was wrong, you could see that we were at least trying. That would be a big help.